Now, the mole is our way for counting numbers of particles, but I don't have an instrument in my lab that can actually, count, oh, how many atoms is in this thing that I weighed out and convert that to a number of moles. What we can actually measure in the lab is always a mass, or sometimes volumes and other things. But mass is the most common thing we'll measure using a balance. And so we need a way to relate how much mass we have, how much we can weigh out, how much does something weigh, and compare that to how many particles does that correspond to, which is how many moles. And the way we do that is through the idea of a molar mass, which just tells us how much does 1 mole of a particular particle weigh. Now, we've been able to figure this out for all the elements that we have on the periodic table. And so I have here a figure from your textbook, but it's really useful. We're looking at helium, and we're looking at its entry in the periodic table. Right? Just as a reminder, this number up here tells us how many protons. There are 2 protons in a helium atom. This is the symbol that we use to represent helium. And then this number down here, we learned in the last chapter, tells us how much does what's the average atomic mass of a single atom of helium in atomic mass units. And so if the average helium atom weighs 4.003, again, it's not exactly 4 because there are other isotopes and because protons and neutrons are not exactly 1 atomic mass unit each. So anyway, the great thing is this also tells us, because of how things are defined, this isn't arbitrary, this is how we've defined things, this also tells us how much 1 mole of helium weighs if we express that in grams. So this 4.003 doesn't have units on it for a reason, and that is because we can say that 1 mole of helium atoms is equal to 4.003 grams. And the same is true for any element we choose in the periodic table. So we look at that average atomic mass, and that is also equal to how many grams is in 1 mole of that substance. So another way we often write this and say the molar mass of helium is 4.003 grams per 1 mole. That's just taking this equation up here and dividing by 1 mole on either side. Right, and now this becomes a conversion factor. These things are equal to each other. 1 mole of helium atoms is equal to 4.003 grams of helium. And so we can use this as a conversion factor just as we would for anything else. Now that tells us how to get the molar mass for any atom. We just look in the periodic table and find this average atomic mass, and that's also equal to the average molar mass, right? So it's this number here is what we're interested in. How do we do that for a molecule? Say we're looking at H2O. Now we have multiple atoms that are present. What's the molar mass of H2O? Well, it's pretty simple. We just take we add up the molar masses of each of the atoms. Add molar masses for each element that's present, for each atom. So for this, we need to remember we have to take into account the subscripts that are here. So in water, there are 2 hydrogens for every molecule and only 1 oxygen. So we would multiply 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. And we would need to go look these up in the periodic table. These I happen to know approximate values off the top of my head, so I'll go ahead and just calculate this real quick. The molar mass of hydrogen, if we look it up in the periodic table, is specifically for hydrogen, is about 1 gram per mole. If we only use like one significant figure, the molar mass of oxygen is about 16 grams per mole. But if we want more significant figures, we'll need to look up the numbers that have digits after the decimal place. But if we want the molar mass of water, mm of H2O, we will get 2 times 1 gram per mole plus 16 grams per mole times 1. I didn't write that out explicitly. So the molar mass of water is about 18 grams per mole. we can get a more accurate value by using all of the digits that are in the periodic table. But that's the basic idea of how we get a molar mass for an element. We just look it up on the periodic table, and the molar mass for a molecule. We just add up the molar masses of each of the atoms that are present in the molecule. Remembering, again, the key thing is to remember all the subscripts, and if there are any parentheses, say you have an ionic compound, like, that's not a good example, but like, calcium phosphate, there we go. So this would be the formula for calcium phosphate. We would need to remember that this 2 applies to the whole PO4 3- here, ion. So that would mean we'd have 3 calciums, 2 phosphoruses, and 8 oxygens we need to add together, just as an example. So in the next video, we'll look at an example of how can we use this idea of moles and molar masses to convert between different quantities, between masses and grams, numbers of particles, and moles of a substance.